Welcome to qnawire.
In this problem, we have a system on equilibrium, and that means that all of our forces have to cancel out so that there is no acceleration. Now let's use that principle to find the friction force exerted on block A. Here we have its free body diagram. First, here's block A, then we have the force of tension, this string pulling it to the right. And then we have the force of friction opposing that tension. And since we know that the block is not accelerating, then we know that the force of friction is equal to the force of tension. Now, how do we find this force of tension? Well, we have this angle over here, so let's try to use that to find or see a path to find the force of tension. We have block W. Its weight is W, and we know that it is connected to the same string. So if gravity is pulling it downwards, then it must have some upwards tension. And in this angle, we see that we have an upwards component and a sideways component. So that tells us that this string at an angle has a horizontal component that represents the force of tension on block A. And then we have another force of tension which represents the weight. It is opposing gravity. So let's give it different names. Let's call this one force of tension on the y-axis and this one force of tension on the x-axis. And here we have some force of tension along the hypotenuse. So we can use a trig to find the force of tension because that is what we need to find the force of friction. So let's set up an equation for that. We know that the tangent of theta is equal to the opposite side over its adjacent side. So that means that we have this force of tension on the y-axis, but we just said that it is equal to the weight. So let's write the weight over, and we have the adjacent portion, which is the force of tension on the x-axis. And we said that that is equal to the force of friction. So let's write down force of friction instead. Now remember that these are pulling in different directions, but we said that they are equal in magnitude, and that is how we are allowed to put force of friction back in this equation. So now we simply have to rearrange this equation, and we find that the force of friction will be equal to the weight of this block over the tangent of the angle. So that is going to be 12 newtons over tangent of 45 degrees. And tangent of 45 degrees is simply 1, so the force of friction has to be equal to 12 newtons. And that is our final answer. And if we want to be very proper with our answer, we have to say or specify that it is pointing to the left. Now let's move on to part B. Part B, we want to find what is the maximum weight we could put so that this block remains in equilibrium. Well, we have this equation. We know that it must be fulfilled for block A to stay in equilibrium. But we no longer have the weight equals to 12 newtons as we had previously. So let's rewrite this equation to represent a new scenario. We have the force of friction equal to some new weight that we're trying to find times 10 over tangent of the angle. And remember that if this block doesn't move, then this angle shouldn't change because we're in equilibrium. So let's keep going with this. Now, what is force of friction going to be? Well, we're given a coefficient of static friction. So that is the maximum amount of friction that the table will provide to us so that it matches the force of tension. So that is the maximum force of friction we can get. So let's solve for the weight, the new weight. We have the force of friction times tangent of the angle. And the force of friction is going to be equal to the coefficient of static friction times the mass times the gravity, and this is the mass for block A, times tangent of 45 degrees. And we're given the weight of block A, and we know that it is 60 newtons. And we're also given a coefficient of 0.25. So let's multiply 0.25 times 60 newtons times tangent of 45. That gives us a new weight of 15 newtons. And that is our final answer.